Alright, got a secret for you this time. Whoa, okay, oh, it's not a very good secret. It's about shooting orcs from a cannon. It's question 15 from your worksheet. Hopefully you're in grade 12 physics watching this. Hopefully you're watching it, period, I suppose. Anyway, it reads, the king, Elvis Presley, fed up with stupid, ugly orcs, wants to increase the maximum range of his cannons to 500 meters. Cannons are placed 25 meters up in the castle. Like, that's my castle that I drew. What muzzle speed should those cannonballs have? And hopefully we'll get 68.3 meters per second out. One thing that's not here that we have to understand is this question comes after doing a few other questions where you're using an angle of 45 degrees. So your maximum range for a projectile under no air friction or air resistance occurs at 45 degrees. So that's not given in the problem, but something you need from class. Right, so I got my diagram set up. I got my orcs here on the right, getting hit with hopefully a cannonball 500 meters away. This question plays out similar to some of the other questions that we've done already. We're trying to find the magnitude of the velocity of the cannonball. We're going to set up two equations. We're going to solve a system of equations. Gets a little mathy, but hopefully by the time you watch this video, you actually have some experience and I'll be able to do this one a little bit faster. So, things we know. We know our X position, 500 meters away. Final Y position is on the ground. It's 0. Initial Y position. So this is a little bit different. We didn't have one that's up above before. It's above the ground of 25 meters, just to help give a little bit extra range there. We have our angle, 45 degrees. Make sure you're in degrees, not radians. We've got our orcs. That doesn't matter in the problem. And I got everything else. Okay. So as before, start with your definition of kind of how velocity breaks up into its components. X component is equal to the magnitude cosine of the angle. Y component initially is the magnitude sine of the angle. So remember, in the Y direction, the velocity is constantly going to change because it is accelerating. In the X component, it will remain constant. Okay, it will not change at all. Right, and that'll be very important later on. First, analyze the motion in the x-axis, the x direction, and there's really only one motion. The x component, which is v cosine theta, equals distance traveled over time. So I'm going to just work with that part of the equation, and I'm going to solve it for time because I know now I've done enough problems like this. I'm going to eventually need that. So the time is the range, the x-axis horizontal distance traveled over v cosine of 45 degrees. And I'll work out the cosine of 45 degrees a little later on. It's a decimal, it's irrational. By keeping it cosine 45, I'll keep my numbers exact. I'll call that equation number 1. So if you're watching this video and you didn't watch the video on how to do question 10, you may want to go back and look at question 10. I go into a lot more detail of where the math comes in. All right, so there's our first relationship. The second relationship will be the position in the y direction relationship. dfy equals d initial in the y plus v initial in the y times t plus 1/2 a g. A is g, 1/2 gt squared. So that's just your formula for figuring out your position in the y direction after a certain amount of time, given initial velocity and given acceleration and given an initial position. Okay. Fine. All right, so we'll rearrange that, put some zeros in, put some numbers in, and substitute for what the initial velocity in the y direction is. So my final position is 0 because I land on the ground, the cannonball. Initial position is 25 meters up. Initial y velocity is v sine of my angle. There's the t still there. And minus 4.905, that's which is half of 9.81, and negative because it's acting downward, and t squared. That is my equation number 2. So again, notice what I did. The initial velocity in the y direction, I'll point it out here. That as it is useless because I'm given the angle. I'm going to incorporate and use that angle. I'm trying to find magnitude of the velocity, so I'm going to rewrite my equation to incorporate angle and magnitude of the velocity. Booyah. Okay, now we do our substitution step. So everywhere I see a t in equation 2 will change. So it's v sine 45. And then my t is now 500 over v cosine 45. Minus 4.905, 500 over v cos 45, and we are squared. One equation, one unknown. Careful with the math. Okay, if anything's going to destroy you here, it's the math. V sine 45, v cosine 45 divide out. Cosine 45, sine 45 are the exact same ratio. It's like 1 over root 2 or something like that. The v's are the same, they divide out. So I just have a squared v over in the end. So again, once I'm careful with that, I don't have anything to worry about. Don't forget that 500 still there. I'll circle it in red. Okay, nothing happened yet. So it's 25 plus 500 minus, and I'll work out some numbers here. 500 squared times 4.9 is going to be a big number. 0.5. 1,226,250. That is over v squared, and the cosine of 45 squared is 0.5. A little bit more simplifying, bring the numbers without the v's to the left. Negative 525, added them together, equals negative 2452500 v squared. So I got the numerator by dividing by that 0.5 in the previous step. Okay, so just working it out. Cross multiply and take my time with my math. Divide both sides by the 525. Make sure everything should work out to be positive. And we get 4671.43. Just keep a couple of decimal places. Square rooting gives us, lo and behold, 68.3 meters per second. So add just enough gunpowder so that those orcs do not stand a chance. Once again, going through the problem, reviewing the steps, set up a diagram, always very helpful, possibly entertaining. Set up your equation for motion in the x direction, and then your equation for your position in the y velocity, position in the y direction. Rearrange for t in your x direction equation. Substitute that into your y position equation. It looks a little hairy, but you've done worse math. I've seen it. And then work it out carefully, and you get yourself 68.3 meters per second.